Good afternoon. We are Group 40. I'm Shuyi, the group leader. Today, we'll demonstrate Movie Hub, our full-stack web app for browsing movies, tracking preferences, and sharing reviews. Movie Hub is deployed on Vercel and Render. Our front end uses the Vite for React framework and React Router for routing, as well as ShadCN and Tailwind CSS for reusable components. The Express server is built on Node.js and provides mashup responses from sources like external movie APIs, such as TMDB and OMDB, Firebase, and our MongoDB database.
First, let's look at the register page. To register an account, new users submit a form with their email, password, and display name, which sends a post request to the server. A Firebase user is first created, then a new user document is created in the users collection in MongoDB, linked via their Firebase user ID. By using database transactions, changes can be rolled back upon more errors. If both entities are created successfully, the server returns a custom token to the client that can be used with the Firebase sign-in with custom token function to authenticate the user. As you can see, a new user document has been created with the auto-generated Firebase user ID. We chose to use Firebase as an abstracted authentication solution as it handles all persistence and tracking of authentication state and user data. We have even made this data accessible via the auth context provider that wraps the entire application. Next is the forgot password page. Registered users who intend to reset their password may submit this form to have a password reset email sent to their inbox, courtesy of Firebase as well. For existing users, they may log in to Movie Hub via the login page. Behind the hood, the login page uses Firebase authentications sign in with email and password function. Upon logging in, users are greeted with the homepage where the top 10 upcoming, top-rated, popular, and trending movies are featured in carousels, along with short introductions and welcome sessions for users. The most popular movie is featured at the very top of the page. The homepage employs a home loader function, making full use of React Router's root loader capabilities. This function calls multiple endpoints to get the top 10 movies of those four lists, as well as a list of genres and their IDs. These responses are combined and written as loaded data, and that is available instantly upon page load. These are the main endpoints that contribute to the home page's data. The first page of each movie list is taken, and the first 10 are selected to be returned in the API response. That's all from me. Right now, I would like to pass it to my teammate Henry Shinmanru.
Each movie card or item has several features. At the top right of each card, users have options to directly add the movie to their watch list, add it to their favorite list, and toggle for more information on the movie. These are the endpoints called to perform these actions. The endpoint modifies the user document or the watch collection and returns a success or error message, depending on the situation. As you can see, the movie ID has been added to the user's watch list, and a new watch document ID is linked to the user. You can see that this is the new watch document linked to the movie at title, and it has also been flagged as a favorite. The functions that abstract these profile-related API calls are passed down from a profile context provider, which wraps the whole web app. Each function uses chain or nested promises and async await to make the changes via RESTful request. They consequently refresh the profile state containing the Movie Hub user data and even handle success and error throws based on the message returned by the response.
Upon clicking elsewhere on the movie card, the user will be brought to the movie page. This page shows extensive details about the movie, including cast and crew details, media, fun facts, reviews from TMDB and our own site, as well as similar movies. The endpoint called by the movie page loader function uses this controller. The data is combined from three sources: TMDB, OMDB, and our MongoDB database. The OMDB data and our site's review are attached to the TMDB data on the server side and returned to the client. Users are also able to add or remove from watch list and favorites via the buttons on the top right of the page, like in the movie cards. In addition, users may add, edit, or delete their feedback on this movie in terms of rating and review. These are the endpoints that are called by the add review, update review, and delete review functions. The server inserts or edits a relevant watch document's feedback property that ensures that is linked to the user. Here is what happens when I add feedback. You can see that a new watch document has been created with my submitted feedback. Here is what happens when I edit my feedback. You can see that the rating and review has been changed. As you can see, upon deleting, the rating and review are set to null again. Next is the Discover page. This page shows a complete list of server paginated movies, sorted by the category tab that is selected above. Similarly, a loader function is used to load the data before the page content is shown. These are the endpoints responding to the Discover page loader, and they are almost identical. As you can see, the page value is passed to the endpoint, which is forwarded to the TMDB API call. The server pagination approach avoids passing too much data to the client, which might slow it down. Next is the filter page. This page allows users to browse movies using a very extensive filter. This page supports filtering by metrics such as genres, release year, average votes, and runtime. All the filter parameters are sorted in the URL, so your results are shareable to other users. The filter loader function handles the update when new filters are applied. When the filters change, the loader function runs again, fetching the results based on latest requirements. To get the latest results, the loader sends a GET request to the route that uses this Discover Movies controller, passing on the parameters after a bit of refactoring.
Next, we have the search page, which allows users to find specific movies, like the filter page. The search query is stored in the URL, so users may copy the URL to share them with other users. The search loader function handles the update when the search query is updated. When the query changes, the loader functions run again, fetching the latest search results.
Last is the profile page, where a user can manage their profile data, as well as their watch list, favorites list, and reviews, and even view the number of visits by other users to their profile. To edit their display name, the user can press the pencil icon beside their name and submit the form with their new name. Submitting this dialog form consequently sends a patch request to the server. The update display name controller is the one used to handle this patch request. It not only updates the display name of the Firebase user, but also the one saved in the database as well. As you can see, the display name has been updated to the new value that was entered earlier. Another feature of the profile page is to trigger a change password email, which works identically to the forgot password feature for unauthenticated users. If a user intends to share their profile with other users, they may copy a public URL to their account using this button. This public URL is accessible by any authenticated user on MovieHub. In this case, instead of using profile context state for profile data, the profile page programmatically uses a loader function to retrieve the target user's data. This is the profile loader function, which serves to get another user's profile data for public viewing. This is the get user profile controller, which responds to that request. As you can see, sensitive data is excluded from the response, and the server records a profile visit from the visiting user. After having completed this assignment, I feel really grateful for the opportunity to hone my skills in full-stack web development. Although I've had a fair amount of experience with web development, I don't always get the chance to adhere to proper coding practices and conventions. However, in this assignment, I believe my group and I did a really good job in designing the tech stack for this project. And I think we learned a lot doing research on the best approach towards this project. All in all, I feel very satisfied of my achievement, and I look forward to being able to improve further in this field. After having completed this assignment, I feel really grateful for the opportunity to hone my skills in full-stack web development. Although I've had a fair amount of experience with web development, I don't always get the chance to adhere to proper coding practices and conventions. However, in this assignment, I believe my group and I did a really good job in designing the tech stack for this project. And I think we learned a lot doing research on the best approach towards this project. All in all, I feel very satisfied of my achievement, and I look forward to being able to improve further in this field.
Looking back at this project, I've learned how powerful it is to integrate Firebase for secure, real-time authentication while still maintaining full control with custom backend using MongoDB. Setting up things like custom tokens, root loaders, and using context providers made me realize how everything connects from the moment a user registers to how data is loaded and displayed on the homepage. It taught me to think beyond just code to really focus on architecture, scalability, and the user journey. That is all from me. Thank you so much.
This part of the project really helped me appreciate how dynamic user interaction can be when backend and frontend are tightly synced. Managing watch lists, favorites, and profile updates in real time showed me how important it is to maintain clean API structures and state management. Using context providers to pass down logic made the app feel responsive and scalable. It also taught me how to handle user feedback gracefully through error handling and post messages. Basically, making the whole experience feel seamless and personal.
Throughout this walkthrough, I demonstrated the structure and functionality of our movie web application, focusing on how data flows between the front end and back end. From the move home and movie pages to discover and filter, each page uses a loader function that retrieves and prepares data server side before rendering. In particular, the movie page showcases how we enrich TMDB data with OMDB and our own database reviews. Users can interact with the content by adding movies to their watch list or submitting feedback, which updates the MongoDB watched collection through the user controller. The discover and filter pages highlight how we optimize performance through server-side pagination and URL-based filters, making user experiences both fast and shareable.